The motivation for my app goes back to 5, 6 years when I first started using Headspace for the first time and noticed that the only real mechanism of feedback that these apps provided was either the amount of time you had trained or the number of days you had spent on this application. And there was no other feedback based on how good the quality of your practice was. And I wondered if we could introduce some biofeedback mechanism to make this practice better. So I decided to give a shot at building Calm Down, which basically combines audio with heart rate to give an AI-based personalization feedback mechanism.
Let's see how it works. The person wears the watch on the wrist and opens the Calm Down app. The person clicks on the start button, which starts collecting the heart rate as a background service. And then the person listens to the audio file that is provided, adjusts the headphones, and listens to this for approximately 10 minutes. While the person is listening, there is over the internet, real-time heart rate is collected and fed into the system, which saves this data for processing by the ML models. So this is basically a call which updates the heart rate into the file and shows what the person's heart rate looks like in real time. Once the person is done, he or she clicks on feedback and sees what the stress level is like.
This is how Calm Down works. So after using touch as a modality to interact with the stopwatch, the user is fed the audio, which is a pre-built speech of calming a person down. And then the user's heart rate is collected in real time. This collected heart rate is then fed into two models. The first model kicks in when the user is initially using the app, and for the first 20 hours of practice, the model only tells whether the user is stressed or not. But once the app has enough data to predict on the second model, which tells more about the quality of the practice, then that model kicks in. For now, I've only implemented the first model. So the first model, which predicts stress, is based on Swell's database from Kaggle. So in this study, which was done on 25 subjects, hours of data was collected and various sensors were put on people, ranging from collection of body postures to facial expressions to ECG signals and to even computer logging that the user was doing. So I created a heat map of all the features and based on the features that I could provide from the heart rate collected, I zeroed out on SDRR, HR, and mean RR. With this data, Swell's data, and the features that I wanted to pull out, I was able to build a model with 95% accuracy, which is a random forest model. But I also know that there is tons of research which has combined different modalities of the same data, such as facial expressions, to achieve 99% accuracy. So that could be a good next step. And then in my model, based on the predictions, I classify on thresholding whether a person is highly stressed, medium level stressed, or low, the stress level is low. The model 2 is more tricky and is still in the making. It is based on MIT PhysioNet's data for various meditation techniques. I chose Chi meditation because that was closest to the kind of meditation that audio-based apps provide. So here I had 8 volunteers who had both like 1 hour data of each for pre and post meditation. I again did the same thing, built a lot of features in heat map, and I was able to achieve an accuracy of 85% with KNN, but I highly suspect this to be an overfitting, like the ROC curve is pretty bad here. And I tried multiple methodologies. I tried time domain features, frequency domain features, even point care plots, but I was not able to achieve the kind of accuracy that most of the papers claim to have done. So I feel that could either be because I'm not doing, like I'm overfitting the data, or I also think it could be because of sparse data that's available. I tested this model on 5 users at MIT, and I can attest that the first model works pretty well because there was this one person who was doing this app after coming from squash practice, and his heart rate was really high. And I thought the model would definitely predict him as stressed, but he was actually predicted as not stressed. So I think the first model works pretty well. I also noticed that standard deviation of heart rate is a much better measure for calmness than mean heart rate, considering that people were calm during their practice. Some good level next steps would be to improve Model 2. There's been a recently published paper by Google in January 2023, which has used Atomic Balance Index to solve this problem with really high accuracy. Some other good next steps could be to integrate this application with other modalities like haptics or posture to achieve a better accuracy and measure of stress. There's also potential to personalize from various perspectives. For example, you could see which session works better for which person, or what content of the audio relaxes a person more. To share this interesting blog post that I came across from FitMind, which says that we just don't know enough yet to make accurate claims about HRV and meditation. And I think that's interesting because that potentially also answers why these apps with billions of dollars of data have not yet decided to invest in this technology. But with new research coming every day, there's a lot to find out. I wanted to conclude by sharing the tech stack that I had for my project. I used multiple languages and Android, which I definitely advise against. It's a lot of work and a lot of dependencies, and then Telebit to connect over across the internet, and Python Flask for the web app, and all the machine learning Python libraries for building the model. Thank you.